Hey there! Welcome back to the Nauctis on YouTube. Large ships such as cruise ships and container ships generally have large-sized engines. These engines are not only used to propel the ships, but also serve as diesel power generators for various industries. These massive engines can weigh thousands of tons and have even set world records. With their size and advanced technology, these giant engines can move large ships across vast oceans and carry heavy cargo. The development of ship engines began in the early 19th century, when large ships still relied on wind and human power to sail. Over time, the invention of the steam engine by James Watt in 1769 revolutionized the maritime industry, especially in engine technology. Steam engines became the primary source of propulsion for ships in the 19th and early 20th centuries. As the 20th century progressed, steam engines were gradually replaced by diesel engines in large ships. Compared to steam engines, diesel engines were considered more efficient, lighter, and required less maintenance, making them the preferred choice in modern shipbuilding. Not only were they more efficient, but diesel engines also allowed ships to be larger, faster, and more reliable than their steam-powered counterparts. In addition to diesel engines, modern ships are now also powered by electricity and natural gas. These engines enable large ships to sail at higher speeds, while carrying larger cargo capacities. So, how are these giant ship engines manufactured? It's important to note that the production of engines for large ships is a time-consuming process. Crews can spend tens of thousands of working hours on each unit. Most large ships use two-stroke diesel engines because they are more cost-effective compared to four-stroke diesel engines. There are several advantages to why the majority of large ships opt for two-stroke diesel engines. Some of these advantages include fuel efficiency, greater efficiency, lower operating temperatures, easier maintenance, and environmentally friendly exhaust emissions. The production of ship engines begins with the creation of the most important and largest engine component, which is the crankcase. The crankcase and other engine components are manufactured in a specialized metal processing foundry. The foundry for making crankcases and other ship engine components is located in Bavaria, Germany. Before creating the crankcase, workers prepare the necessary materials, including steel pieces, raw iron, graphite electrode metal sheets, and silicon carbide in specific quantities determined by an engineer. These materials are collected until they reach a weight of tens to hundreds of tons, and then they are melted in a furnace at a temperature of 2,732 degrees Fahrenheit. Once the material has reached 2,732 degrees Fahrenheit, magnesium is added to the molten material. This mixture is then poured into giant molds filled with quartz sand. The molds are left to cool for weeks before they can be opened. Once cooled, the crankcase is removed from the mold and cleaned of any adhering sand using a vibrating machine. After that, the crankcase undergoes a shot peening process using iron balls to ensure it is completely clean. Another important component in giant ship engines is the crankshaft, which is made from steel and carbon materials. The manufacturing process involves placing the crankshaft material into a cross-diverging machine using a hydraulic control blew hammer. Cross-diverging is a forging process using a closed mold that produces the desired shape. In this process, the crankshaft material is forged at very high temperatures to achieve the required length. The hot crankshaft is then subjected to heat treatment or quenching in water to make it stronger and harder. Next, the cooled crankshaft is heated to a specific temperature and forged again using a mold with a weight of up to 3,500 tons. Afterward, the crankshaft moves to the 𝗤𝗂𝗃𝗫𝗁 stage, which is a cleaning process to remove any remaining material from the forging. After passing through the 𝗤𝗂𝗃𝗁 stage, the crankshaft is sent to a CNC milling turning machine for machining. This process results in components with the specified dimensions. Once the machining process is complete, the crankshaft undergoes another 𝗤𝗂𝗃𝗁 process to further strengthen and harden its structure. The next step is magnetic particle inspection, where the crankshaft is carefully examined to ensure it meets all procedures and is safe to use. Next, there is a dynamic balancing process where the component is rotated at high speeds using special electronic equipment. This process is used to measure any imbalance in the tested component. After dynamic balancing, the crankshaft goes through a final inspection and is placed in a washing machine, where it is given a unique engine number. Once all the engine components have been made, the next step is to assemble them into a complete, giant ship engine. The first component to be assembled is the bed plate, which will serve as the foundation for the engine components. Once the bed plate is in place, the crankshaft material is installed inside it. After the crankshaft is fitted into the bed plate, the frame box is assembled. The bed plate and the frame box form the crankcase. Inside the crankcase, the connecting rod is installed, which converts the reciprocating motion of the piston into rotational force that is then transmitted to the crankshaft. The next step is the installation of the cylinder frame block, which contains the combustion chamber components and combustion control devices. The final stage involves the installation of the turbocharger, which utilizes exhaust gas energy to compress air and increase engine output. Meanwhile, smaller components like pistons and conrods are also assembled to save assembly time. Once the parts are combined, they are brought to the main engine while waiting for the engine block, which is undergoing painting. The painting process is not only for aesthetic purposes, but also serves as a preventive measure to prevent corrosion that can lead to metal material degradation. The next step is to bring the separated engine block components, such as oil pan and cylinder head. To join them, a special sealing method is used to prevent oil leakage due to high pressure within the engine. After all lubricating fluids are added, the engine undergoes an operational test. This test involves a series of parameters that determine whether the engine is ready for operation. If the engine passes the test, it can be installed in the vehicles that require it, such as tanker ships, container ships, and cruise ships. Some of the largest ship engines in the world include the MTU Series 8000, built by the German company MTU. These engines are designed to power the 𝗤𝗂𝗃𝗫𝗁 ferry in Malta. The ferry has 4 20-cylinder diesel engines, each measuring 7 meters in length, 2 meters in width, and 3.5 meters in height. These ship engines weigh up to 48 tons and can hold up to 8,000 liters of fuel. The 𝗤𝗂𝗃𝗫𝗁 engines consume up to 2,000 liters of fuel per hour. Another giant ship engine is the 𝗦𝗽𝟐𝑥92DF. This engine holds a Guinness World Record as the largest and most powerful Otto cycle engine ever built. Unlike diesel engines, where fuel is mixed with air inside the cylinder, the fuel in Otto cycle engines is pre-mixed outside the combustion chamber. The 𝗦𝗽𝗐𝗐 engine stands at 16 meters in height, equivalent to a 5-story building, and weighs up to 2,100 tons. Building this engine took a considerable amount of time and involved a workforce of 3,125 people. The 𝗤𝗂𝗃𝗃 engine was specially constructed for the latest cargo ship of the 𝗖𝗹𝗃𝗁𝗁 company in France. 𝗖𝗹𝗃𝗁𝗁𝗁's cargo ship is the world's first LNG-powered cargo ship with a capacity of 23,000 TEU and the ability to carry loads of over 30,000 tons. Another giant ship engine is the 9290 MEC, built by Mitsui E&S Machinery in Okayama, Japan. This diesel engine is 14.6 meters long, 17.7 meters tall, and has 9 pistons, each with a diameter of 90 centimeters. The pistons in this engine can generate up to 54,900 kilowatts of power. This engine is designed to power various types of ships, including tankers and container ships. However, among all the previously mentioned ship engines, the largest ship engine in the world is still the 𝗤𝗂𝗃𝗃𝗁𝗁 RT Flex 96C. This giant engine is built by the Finnish company 𝗤𝗂𝗃, which has been in existence since 1834. The 𝗤𝗂𝗃𝗃𝗁𝗁 RT Flex 96C engine is designed for large container ships that use heavy fuel oil. It measures 26.59 meters in length, 13.5 meters in height, weighs over 2,300 tons, and generates 80.08 megawatts of power. The 14-cylinder version of the 𝗤𝗂𝗃𝗁𝗁 engine was first operated on the container ship Emma Maersk in September 2006. The design of the latest engine is similar to the older version of the RT Flex 96C engine, but it includes common rail technology. This technology replaces the traditional camshaft, chain gear, fuel pump, and hydraulic actuator system. It maximizes performance at lower RPM, reducing fuel consumption and emissions. The engine has special bearings, which keep the piston rod vertical, creating a tight seal under the piston. As a result, engine lubrication is divided into cylinder and crankcase sections using different lubricants. The cylinder is continuously lubricated with used-up lubricant injections, which are specially formulated to protect the cylinder from wear and neutralize acid formation during high-sulfur fuel combustion. The crosshead design also reduces lateral forces on the piston, maintaining cylinder liner wear to around 30 micrometers per 1,000 hours. As the piston descends, it compresses the incoming combustion air into adjacent cylinders. This also serves to dampen the piston as it approaches bottom dead center, removing some of the load from the bearings. The engine is uniflowed through electronically controlled hydraulic-operated exhaust valves, eliminating the need for a camshaft.